Now we're going to learn how to solve logarithmic equations. And the interesting thing is the process is very similar to the one where we learned to solve exponential equations. In fact, if we take the same rules, and everywhere it says exponential, write logarithmic instead, and everywhere it says logarithm, write exponential instead, that's how we solve logarithmic equations. Okay, so we're going to get the logarithm alone, take an exponential of both sides, and solve for the variable. Now, it does come with warning number 21. Remember that we are only allowed to take the logarithm of positive numbers. So whenever an equation starts out as a logarithm equation, once we get an answer, we're going to have to go back to the very beginning and make sure we're only plugging in positive numbers to the logarithms. Alright, so let's start with this example. The first step is to get the logarithm alone, which we do by dividing both sides by 7. The next step is to get rid of the logarithm by taking an exponential. And just like we did when we were doing it the other way around, we want the same base. So this is a log base 2, so I'm going to take an exponential base 2. Meaning, I'm going to take 2 to the left-hand side and 2 to the right-hand side. Now, this 2 and log 2 cancel, so I'm left with x is 2 to the negative 3/7, which can also be written as 1 over 2 cubed 7th rooted. Okay? Now, that's a perfectly acceptable answer, but I have to go back to the very beginning and say, is the number I'm plugging into the log positive? Well, the number I'm plugging into the log is x. Is x positive? Yes, so we're good. Okay, let's look at our second example. Here, the first step is a little bit more complicated than you may think. To get the logarithm alone, well, there are actually 2 logarithms. And I'm okay with that. It's just that I have to have only one term on each side of the equation. And I don't know a way to combine the 3 with the log. But I do know a way to combine logarithms together. So I'm going to get the logarithms on the same side of the equation. Because now, the sum of 2 logs is the logarithm of the product. Okay, now I want to get rid of the logarithm, so I'm going to 3 both sides. Or do 3 raised to the left-hand side equals 3 raised to the right-hand side. Here, the 3 and the log cancel. I'm left with the x plus 1, x minus 1 equals 27. Now, in order to solve, I need to get x alone, or I need to at least be able to factor, which means I need the 0 on one side first. So I'm going to multiply out the left and reevaluate how to solve. Here I only have 1x squared, so I want to get it alone and solve for it. Okay, this gives me 2 answers. Now, remember that you have to check logarithm answers, and I want to do them separately, so I'm going to write my 2 answers separately. Now let's go back and look. The first answer is square root of 28. Now just for simplicity's sake, let's figure out kind of what that equals. 28 is bigger than 25, so this is slightly bigger than the square root of 25, or 5. So this is a number about 5.5 maybe. If I plug in a number that's close to 5.5 for x, I get 6.5, which is positive, so we're good, and 4.5, which is positive, so we're good. So this answer works just fine. Now, this one is about minus 5.5. If I plug it in here, I get minus 4.5, which is a negative number. I can't do that. That must mean that we totally throw out that second answer.